So I'm going to, and okay, so last time we talked about what system, I want to do some reviewing. Most of it is just kind of review, and then the new material will actually be just in the last part of the lecture, which is on generics, which is really kind of short. And you know what, maybe I should just start since, why don't I start with the new material? New materials really doesn't take very, I was kind of surprised. I spent a lot of time reviewing from last time, and then I did the new material, and it hardly took me any time. Why don't I just start with that? It's not going to be on the quiz. So there'll be a quiz on Wednesday on system array copy and the for each loop. So let me just quickly go over the new material. And this new material, which I'll review that a little bit next time next time as well. But we need that for something really important called interfaces. Not graphical user interfaces. There's Java has something called an interface. It's really important. We'll use a lot in this course. Okay, so let me just share the screen here. Let's see, hopefully I can find my files better than last time. And let's see here. Okay, here, so now let's see, let me see files. Okay, so let me just go right here. And it's generally just open it from here because otherwise generics. And so I think this will be okay. And we've seen generics before. And we've seen it with arrays. In fact, why don't we open up, I think I have an example with arrays. So let me just open up Eclipse. And I think I have an example. So do you remember we quickly did, both of you were in my class last semester. Do you remember we quickly did, like, we didn't really have a lot of time. We had one assignment where we used array list. Remember the array list had that diamond operator? Here, let me just show you an example. Yeah, so let me just show you an example right here. Okay, so this is an example. I'll go back to this, but look, like here on line 7. Let me go to the notes and I'll come back to this. But there on line 7 is an example of oh, hi, Michael. So there in line 7 is an example of an array list. And the reason I'm showing is that in the diamond operator, you see string. That's a generic, right? So that just says this array. An array list is like an infinite, an expandable array. And so when you see that generic term, it just means that array list can only store strings. Okay, so let me go to the notes, and then I'm going to come back to this. And this shouldn't take me too long. And then I'll just review. I'll just review the stuff for last time that hopefully will help in our quiz. Okay, so let me go back to here. So now you should see a slide that called generics. There's only like 5 pages in this. It's not really a lot. So here, I think I need to use my finger. Okay, so by the end of the lecture, you should know the meaning of the term generic. Well, we kind of know it already. It's this. It's the diamond operator. It's not really. It doesn't seem exciting, does it? It's vaguely exciting. It'll be more exciting next time. It's like Wednesday. Oh my God, I can't wait till Wednesday. Okay, so anyway, okay, so so if we just looked, okay, I can't remember when generics was introduced into the Java language, if it was, does this work? Yeah. I don't know if it's Java 1.5. Like when I first started working with Java, we didn't have generics. All we had were just non-generic type classes. So like if you look there on slide 3, the array list class would look something like that. It would say public class array list. And then we have these methods. So like there's 2 methods that we use a lot in array list. One is called add, and it actually returns Boolean. And that means it was successfully, the element was successfully added to the array list. And then another one called get. And before generics, it would always return object. Remember, object is the highest level class of all, right? So every class extends from, like, a string is an object. If we write our own, any of our own user-defined classes like person, that's an object with an uppercase O. So the add method, you could pass in any kind of object, and it would be added. The get method would return something of type object. Now it became a little bit more specific when we added generics to it. So let's just look at the, okay, so we're not using generics now. See the slide 4. Do you notice that you don't see the diamond operator? It's missing. It's sad. Okay, so, oh, hello, Yair. And then, so where am I? Okay, so it's just an ordinary array list, okay, which means you can add any kind of object in the world to this array list. You can add an integer, you can add your own user-defined class, and an object from your own user-defined class. You could add a string. So notice what we're adding here. First we add a volcano. So to add a value to an array list, you have to use a method. So we add volcano. So we know it's a string because it's inside double quotes. And the next line, well, we're adding I'm assuming we have a person class. So person, so there's the person constructor. First name is J, last name is S, and the age is 20. Okay, so we've added these two values to the array list. And now we want to do a get. So you notice how we're doing get 0? That means get the first element that was added to the array list. Now it turns out that's a string. We're assigning it to string. And note, what do you see that we have to cast? See, string, because remember the get method, why do we have to cast? Because the get method, if you look there on slide 3, can return any kind of object in the world. We're not guaranteed to return, we want to assign the get to that variable str, which is a string. We're not guaranteed that the get method returns a string. So we have to basically tell the compiler, I guarantee you the first element added to the array list was a string, that the element at position 0 is a string. So we tell the compiler, that it's okay to assign the value returned from the get method to str. See, str is defined as a string. See, if we did get 1, you'd get you get an error, because then you'd be trying to assign a person to a string. So without generics, when we use the get method, you have to cast. When you do the get, you'd have to cast to the right type of object. So in this case, if you want to assign the get 0 to a string, we have to cast. Okay, so now I'm on slide 5. And so now this is how you would write a class. If you actually wanted to write a class with generics, and we define classes, we eventually will, I think at some point, write a class with a generic. And it's usually for like a class where it's a collection of, for an object, a class that is going to store a collection of stuff. Like an array list contains like it's like an array. It contains a collection. There's something called a linked list. It contains a collection. Okay, so this is something you've never seen before. You go public class, give the class a name, and then after the class name, you see a generic. And see that E there? It represents a class name. So in this case, when you're defining a class with a generic, that E is a variable that represents a class name. So let's say we defined an array list. We went array list string. Let's say the main method. Do I have an example on the next slide? So there, like on that next slide 6, see how we're going array list string ARR? That string would be, E would become string. Yeah, well, it says right there, the compiler replaces the E on the previous slide with string. So when you define an array list with a generic, you're passing a class name to the generic variable. So now the add method, when you use string in the diamond operator, the add method can only accept, this is the important part. The add method can only accept strings, and the get method is guaranteed to return a string. Right? So I have to use my finger here. Okay, yeah. So if you use generics, the add method, and this file's online, the add method in the array list class, really the parameter is add string. And for the get method, the return value is string. So why is this important? See how now we don't have to cast anymore, because now if you use a generic, the get method is guaranteed to return a string. And I'm going to show you in a minute that the compiler will check to make sure you're only adding strings. You see here, we didn't cast, like on slide 8, like on page 4 there. So we declared an array without generics. We added volcano, and now you're using the get method, but we didn't cast. But now the get method, because we're not using generics, it's returning the highest level class of all, object. Without generics, the get method is not guaranteed to return a string. But with the generics, if you go array list, with the diamond operator string, it is guaranteed to return a string. It's really not, that exciting in a way, but okay, so here's another one. This would give you'd actually get a compiler. We're gonna check this in Eclipse. We create an array list and it says, oh, we can only add integers to this array list because that's what's in the diamond operator's integer. Oh, we add volcano. The compiler is not gonna like that. You'll get a red dot. See, because the get method has to return an integer. If we add a string, we're not gonna get an integer back. So there's only, because we have the generic variable is integer, we're only allowed to add integers. So that's the exciting part. There's really not a lot that's exciting here. The generic variable restricts the type of data that we can add to the array list. And the get method will always return that type of data, so we don't need to cast. So I think any question before I pull up Eclipse, and we'll just see a few examples of this. Okay, so let's just look at this. Okay, so look there on line 7, and okay, so we add, why is this, we're probably saying I'm not using S. Yeah, I'm not using it. That's why I get the warning. Or yeah, it's kind of a warning, that yellow, I'm not sure what that is. A bubble, or I'm not really sure what that is. Okay, but it's yellow, the yellow balloon there. Okay, so so you should see a Java file there. And so line 7, we create an array list, and string is the generic variable. Oh, so we can add cat because it's a string, it's in double quotes, dog is in double quotes, and the get method is guaranteed to return a string. That's what the generic variable does for us. Okay, so the next line, okay, like 15, oh, it's an array list of type integer. We add 7, and that's okay because 7 is an integer. Now let's just look at some of these. Now I'm going to go back and put some of these compiler errors in. Okay, so let's go back up here. So let's say to that first array list, the one defined on line 7. Let's add an integer to it. It's going to give me a warning because it doesn't like me going new integer. But do you see how I'm getting a compiler error? There's another way to do it. They don't like us. They don't like us going new. Integer is actually this wrapper class. It's a class name. But if you want to create an integer object, you're just supposed to say the integer name. You're not supposed to invoke the constructor. It's a special kind of class. It's wrapper class. So, but in each case, we get a compiler error. Oh, because why? Look at the comment in line 7. Can only add string values. Oh, look, we're adding bad, comma, semicolon. We're adding integer, right? We can't add an integer. The ARR list, it says the diamond operator says we can only add strings. So the compiler checks to make sure that if you use generics, the compiler will check. Let me say this again. I've been talking a lot today, students. The compiler will check to make sure the data added to the array list matches the generic type. Okay, now let's look at the array list in line 15. Oh, we can only add integers. The compiler will check. Now I'm going to uncomment this code. So I'm adding 7 on line 16. That's fine. 7 matches the generic variable. Uh-oh, now I'm going to get a compiler error. Why? Because in line 17, I'm adding a string to an array list that was defined with integer. Cat is not an integer object. So that's the great thing about generics. It's going to check to make sure that we're adding at compile time the correct type of data. And it's good because it's easier to get rid of it's easier to fix compiler errors than runtime errors. And then line 21, oh, see how we're not using generics on line 21? So this is like the olden days. Yeah, it takes me back to 2008. Okay. Yeah, I should put out my diary from 2008. I was probably writing about array lists without generics then. Okay. Yeah, my autobiography is going to be very fascinating. Okay, so anyway, okay, so array list, line 21, no generics. No generics. Okay, so we add cat. That's fine. You can add cat, but now look at line 23. We have to cast. See, if I take away the cast, see, look what happened. I'm going to get a compiler error. See, because 21 was an array list defined without generic. So if you use the get method, now you have to, see, look at the get method in line 10, no casting. And here, the line, here, let me do a get here. Integer x is assigned, what was the name of the array list? arint dot get 0. See, I didn't have to cast when I did the get. The get's going to arint stores a list of integers. The get is guaranteed to return an integer. 22, no generics. We can add anything we want. See, I could actually add, let me just show you this. I could actually add, now I can actually add an integer object. See, we can add any kind of object in the world. So now when you do the get, the compiler is not sure, what is get really returning a string? We're trying to assign something to a string variable. So you have to cast now. So there's really not a lot to this. There are actually lots of rules when it comes to generics. And one of the problems with Java is, it's a good thing and a bad thing. They're trying to keep the codes, the older codes, they don't want to break older codes. So when they add new features, they have to make sure the older codes still work. And so when they added generics, it actually made Java used to be, I think, a really very simple language to program in. And once they added generics, it really wasn't. When they added generic, there's things about generics that I look at, and it's hard for me to, because I probably don't use some of these. The documentation on generics is like 50 or 60 pages. There's just some things I don't use a lot, so I have to refresh my memory because it's really, some of it's just hard to read. We're not going to do any of those things in this course, but we're just going to keep it really simple here. But anyway, so I think you know everything. If you need to know anything more about generics along the way, I'll show it to you when you need it. But I think you have all the basic stuff about generics. You're not quizzed on this next time. And the place where you actually use generics on a quiz or an exam is the stuff that we're going to learn on Wednesday, which is interfaces. So we're going to write what's called the comparable interface. We're going to learn how to write a class that implements. First, we're going to learn about interfaces, and then we're going to specifically learn how to write an interface called the comparable interface, which will allow us to compare objects. Because you can compare integers, right? Let me just show you. This is kind of a coming attraction. And then I'll go over I'll review I'll just review if you want to stay for the review. Coming attraction. See, I can go like this. Boolean flag, like 7 is less than 6, right? Because the right side is either true or false. Either 7 is less than 6 or it's not less than 6. And it turns out, well, that's false. But we can compare strings with the less than operator, just like you do in your ordinary math, or the other math classes. Okay, but it's not true of string. So let's say Boolean flag to, let's say cat. This better not work. Okay, I'm going to fill sad. Okay. Yeah, so you get a compiler error now. You can't compare strings with the less than operator. There's a method called compare to. And that's actually, and we're going to learn how to compare objects. Like, we didn't do that last semester in Math 130. So we're going to learn how to compare objects from our own user-defined classes, like a person class. We're going to learn how to compare two person objects to decide which one's bigger and smaller. The programmer makes up the rules. Like for string, it's alphabetical order. It's dictionary ordering. The closer you are to page 1 of the dictionary, the smaller the string. And that's only if it's alphabetic. If it has other characters like numbers and like characters like semicolon quotes, and then I actually have to look up it goes according to what's called the ASCII code. But let's say if it's all alphabetic, all lowercase of the same, either all lowercase. Let's say if it's all lowercase or all uppercase, then it's just then it's dictionary ordering. What do they call it? Maybe that's what they call it, dictionary ordering. Okay, so that's coming attraction. So we will use generics to write our interface. And that's why I want to teach you about generics right now. And we probably will use it later on. We're going to talk about code for linked list. And we'll probably add to it a little bit. So any questions right now? So what I would like to do is, I might have to close my door. It's kind of funny teaching at night. For some reason, the cat bothers me a lot more at night than during the day. And I've never really lectured a lot at night. And yeah, we're in trouble right now. Okay, so I might have to just put her out of the room and lock the door. And hopefully we won't hear her cry. I think I'm going to do that right now. Okay, you need to go. Now, you know a lot about Java. You don't need to learn anymore. Okay. Yes, sorry for the disruption. Yeah, I think she hears my voice, and I don't know, maybe she thinks I'm going to feed her or something. Okay. Okay, so I see him chatting from the, oh, I can't see it. What happened? Well, I'll get to that later. Okay, so students, I'm going to, let me minimize this. And so I wanted to, okay, so I'm done with generics right now, and then we'll do a really nice example of generics next time. And then we'll learn how to, next time you'll learn what you're gonna need to know for the quiz a week from Wednesday. Which the week from Wednesday, then you'll write I'll give you, just ask you to write an interface, a comparable interface. Okay, so I am going to, let's see, close this. And I want to, okay, so where am I? Let's go here. Let's look at these review questions. Let's do some of these from the review questions. And this students, you can open this up at home, or I don't know. You see there, it's in the files area. I think it's also in the module area. Okay, I have the solutions up there, but yeah, I'm looking to see what's outside. It's funny lecturing on Zoom, and I don't know, you see something happening outside through the window. Okay, so let's just look at this. Will be helpful for your, and I'll put the solutions up there, and then tonight also I'll recommend which problems to review. I'm not gonna go over every problem because it just takes a long time. So let's just look at this first one. So let's just go over system array copy, and then I have kind of an interesting system array copy problem, which won't be on your quiz. I'll show that to you tonight too. And then we'll do one or two methods involving the for each loop. So, okay, so let's just review how to do this. Remember the system array copy. All it does is not really adding any new functionality that we didn't have in Math 130. It just is kind of a nice way for everyone to copy the contents of one array to another. So we're not actually using loops. So let's see, let me go, and actually I took a picture of this so I can, let's see here. I'm not looking at my pictures right now. Oh, here they are. So, okay. Okay, so I'm gonna go back to Eclipse. And you should see Eclipse right now. And I have this file called array copy up here. Okay, so, and that should be the array. Yeah, so S of I is initialized. There's nothing exciting about 2 times I, I'm just giving it a value. We declare an array of size 30, and then what we're gonna do is initialize every value. And notice that, okay, line 9, array T is also an array of length 30. And remember, if you don't assign values to a numeric array, the default value is 0. So when you allocate memory for any kind of array, every array value has a default value if you don't assign it a value. Okay, so so let's see here. So the first one says the first problem says let's copy all the values of S into T, and we're going to use system array copy. So let me just write the answer. And students, remember, I'll say this again, at any point you need to leave, you're not hurting my feelings. I don't take attendance. So just stay as long as it's in your best interest. And if you have to study for a test or go to work, or just want to relax, we're all, that's fine. But I'm not encouraging anyone to leave, of course. Okay, so let's see. There's 5. I'm going to just oh boy, T. Okay, so there's actually 5 parameters. So the first and the third parameter, so S is the source. And we'll fill the other ones in. So S is the source, and then T is equal to the target. So we're copying from the source to the target. So remember, the first number, the first parameter after the source is the initial index of the source. The first number after the target is the initial index of the target. And then the very last parameter is the number of elements copied, which in this case, we're copying everything from S into T. So S dot, let's just keep it, you could use 30 and it would work. But if, you know, if we want to go ahead and, you know, change the code, change that 30 to 100, then you have to change line 11 too. So let's just keep it S dot length. And if we ever change the length of S, well, we only have to change it at one point, line 5. Okay, so and now, so now all the values of T should be non-zero. So I'm actually going to write out, I'm going to just use this loop. I think you can just go system.println T or T dot, I forgot what it is. I'm just going to do it like this. Okay, so, and I'm going to use an ordinary for loop less than T dot len to th. And then we'll see that all the values of T have been changed. T square bracket equals, and then plus T of I. And I think that works, okay. Yes, okay, so let's run this. Error exists, oh, it's in that array list. Okay, yeah, we can continue. Some file in my project has an error, so we're gonna get that message. But you see here, initially, remember we declare T, we didn't assign data to it, so all the values were 0. Notice how T sub I is 2 times I, because we copied the values from S into T. And that, so line 11 is what assigned values to T. So any questions on that? And then, and that's the kind of thing I might ask you to write on your quiz, or almost everyone gets this right. Okay, because it's simple and, you know, it's open notes. Okay, so let's just look at the next one. And then, yeah, you might hear the cat. Okay, so sorry about that. Okay, so now we want to copy 11 to 29 of S into 3 to 21 of T. Okay, so so I'm just going to remove that. I'm just going to comment that out. So 11 to 29, array copy system. Okay, so once again, the target is S, and we're going to start from we're going to start from index 11 in S. The target is T. And we're going to start with, we could all mute, that'd be great, unless you're asking a question. And then we're going to go to, so we're copying from S of 11 to T. The number of elements copied is 29 minus 11 plus 1. Great. So it's last minus first plus 1. What did I say, 29? Minus 11 plus 1 is equal to 19. I think that's right. Okay, so that's the number of elements being copied, right? So what are we doing here? So let me just show you. We're going, okay, so what are we copying? We're copying from S of 11 to T of 3. So T of 3 is assigned S of 11. Well, let's do the first few. T of 4 is equal to S of 12, and so forth. That's what we're doing. We're going all the way up to T of, and the very last one should be T of 29. I mean, S of 29. Eventually, we should be getting all the way up to T of 11. Because that can't be right. No, sorry, T of 21. Add 18 to it is equal to S of 29. Please not. Okay, fix that. Okay, so now let's just run this. Okay, so T of 3 should be 22. So all the values will be 0, except T of 3 will be 22, T of 4 will be 24, and so forth. So let's just run this. It's kind of a really basic problem. You see this, what happens? They're all 0, except the values, we copied some values from S into T. So T of 3 is 22. So not really very straightforward. Okay, so, and then, so let's see here. Any question about that one? And so the last two are just really, is just to demonstrate, if I don't even need this one anymore, I just want to demonstrate that, okay, maybe I'll open the door, sorry. She's back. Okay, give me a lecture. Okay, yeah, so too bad the bush cats understood English, but they don't like closed doors either. Okay, so, okay, so now we're going to copy from, this is something that students forget a lot. The source and the target can be identical. So sometimes I've given programming assignments where students had to copy from the source of the target, and they did all kinds of machinations, and they did it really way harder than necessary. They did all kinds of extra system array. It only takes one. So that's what we're going to do right here. Like if you want to delete a value from an array, you use system array copy, but the source and the target, we'll do that later on in the course, but the source and the target are the same in that case. But okay, so let's just do this. Okay, so in this case, we're copying from 8 through 14 of S into 5 through 11 of S. So I'll just make this the last one, and then I'll write the answer for I'll put up the solution file for the other one, because it's almost the same thing. So array copy, and the source and the target are the same. So S is the first parameter, and S will be the third parameter, and then we have two other parameters. And okay, so we're copying from, so we're going to copy from S of 8 to S of 5. And the number of elements copied is 14 minus 8 plus 1. Is that 7? A lot of times people go, we'll do one less. They'll go first minus last. It's first minus last plus 1. Okay, so let me just format. Where do I format? Okay, and so in this case, what do we have here? So then in this case, S of 5 is assigned S of 8 and so forth. S of 6 is assigned S of 9, etc. Okay, so S of 5 will actually be initialized to 10, but after this system array copy, it should be 16. Oh, let's just change all these T's to S's. And you see what happened there? S of 5 became 16. So when we display the S values at 0, 2, 4, 6, 8. Then when you get to S of 5, remember S of 5 was assigned S of 8. So S of 5 is 16, and then we do, so the next 7 values are 16, 18, 20, 22, 24. And eventually, when you get to S of 12, it goes back to 2 times I. So it's not the most exciting thing, but it can be useful for the source and the target to be the same. Okay, okay, so now I do have one kind of vaguely interesting problem right here. And if there aren't any questions, so here's something where you can use a system array copy, and then and they do this in the array list class. So I'm going to just show this other. This is actually one of the review problems. So one of the review problems said, oh well, no, this is not the one that increase array size. So let's just okay, so this is okay. Where's the one? Okay, so this is a solution to a problem, a different problem here. Let me just do this right now. I'm going to let me just create a new file. This is okay. I just can't. You're being really bad. Okay, so uh, this is just an array list example. Increase array. So let me just do this. Another example here. So and I'll just call it array copy example. And I want a main method here. And okay, so my goal, so we cannot increase the size of an array is fixed. If you define it with 10 elements, it has 10 elements, that's it. But you know how like array list, it seems like it's like this expandable array. See, an array list is really a class, and what's underneath that class, there's an instance variable called that's an array. And we're kind of faking, expand. We make it look like this array is expandable, and it's all done with bookkeeping. And I'm just going to show you right now how it's done. Okay, so let's say we have this array here. Let me just an integer array. Let's just call it x. And let's just say it has three. No, let's just say it's three values in it: 9, 5, and 11. Okay, so my goal is I'm going to write a method here that actually is going to return an array of like double whatever x is. It's going to be double. So public static int. And so let's call it increase array size. And let's just call this ARR. And if ARR is null, I'm going to return null. Okay, so let's make it real general. So ARR might be null. Okay, so yeah, okay, so now I have to return it. So I'm going to declare this integer array. Let's just call it temp. And I'm going to assign it the value null. Oh, there's my local variable. Oh, the local variable is of type integer array. Oh, and then I'm supposed to return an integer array. Let's just return temp. And now the method compiles. Okay, it doesn't do everything we want it to do. It will return null if the input's null, but it always returns null. It returns null. Okay, so now let's see here. So okay, so ARR is not equal to null. See, this way I only have to do one return, which is like, and that's kind of my big thing in Math 141 return. So if ARR is not equal to null, what we'll do is we'll just, now we'll assign memory, but it's going to be twice new int 2 times ARR.length. Oh, so temp is now twice the length of the original array. And now let's just use system array copy. And we're going to copy ARR into temp. 0 temp, start position 0, and the length is ARR.length. And that's kind of what the array list class does. When you're adding, so basically there's an instance variable that every time you add, you just assign it to the next array element, the next available array element. And when you've used up all the elements in this array, you double the size of the array. When you try to add, it'll go, oh, is there room for another array element? And if the answer is no, let's just double the size of the array. And it does something like this, exactly what I'm doing right here. It's not really a lot of code. And it kind of looks like magic. Now, if you're new to programming, this might be kind of hard to do or just a bit much. So it's all done behind the scenes. We never know when we add. Who knows it? In the array list add method, it's calling code like that's in that increase size array size method. Okay, so now let's just let's just create a new array here. So int how about y is assigned increase array size, and we'll just pass an x. So y should have all the values of x. It should be 9, 5, 11, 0, 0, 0. Okay, so let's just do system. Let's just use that for loop. I'm just going to print. I'm not going to make a nice output. In fact, let's just use a for each loop to print out the values of y. I'll just make it real simple. So for every integer num in y, I would just system that out print line num. And what we'll see are 6 values. So it should see, and each value being a line by itself, 9, 5, 11, and then followed by 3 zeros. So for every num in y, right, that's what that says. And see, the new, this, okay, so where did we get this? This is the one I have here? Yes. See, where did y get its values from, right? So see here we're assigning. See this increase array size method, what it is returning, it returns temp. Temp is an address where we can find it refers to the first of a list of integers. So y is so y is an address which that refers to an array of integers that has all the values of x plus 3 additional values. So that's what this increase array size method did. And again, here's just an example how we use system array copy. But yeah, x had 3 values, y has 6. So it's pretty wild. And that's basically the big mystery. Yeah, I solved the mystery of the, yeah, so the array list, maybe the array list class is not so mysterious anymore. Or maybe, I don't know, maybe you didn't really, I don't know, probably a lot of people don't think it, but it does, I mean, it looks like magic, right? Add, and you just keep adding and add as many times as you want. Like, how does this happen? And that's really what a lot of, I think computer programming is just bookkeeping, just keeping track of all these things. So any question on this problem right here? So I want to do, I think that, okay, so let's do a couple of the worksheet problems. And so I'm going to ask you to write some methods using for each loops, like, and not the hardest one. I think just with 1D methods, with 1D arrays. So let's just go back to, of course, I might do a different one than I did, or maybe I'll do the same one that I did earlier today. Okay, so let's go here. Is this it? Yeah, okay, so now this is review, yeah. So let me just, okay, so, oh, you know what? I have the wrong instruction and number, I just noticed that. Write the average. That should be, find the large, yeah, I use the same comment. Oh, that's great. So, okay. Okay, so let's just try a couple of these here. Maybe we'll do the get largest and the get, and I'll show you how to do number 6 there. I'll probably show you an easier way of doing it, an easier version of number 6. I'm not going to put that on the quiz right now. So there'll be a couple of methods, and maybe I'll see if there's any more examples I can put up. Maybe I'll look at last year's quiz and put that up there as well. So let's just try number 3. Yeah, I just noticed no one has ever said anything to me that the instructions for 4 were wrong. Okay, so we're gonna write a method using, and the goal here is, I think you could probably do problems 3 and 4 after Math 130 with the regular for loop. So the goal here is just, let's just get an average of we're gonna assume that x is not null and has length 1. We're gonna get an average, and we're gonna get the largest, and let's just, and we're gonna use a for each loop. Okay, so let's just look at 3 and 4 here. So let's just find the average here. So you might actually have, I don't know why I put it. Okay. Okay, I thought I had done some of these already. Okay, let's do, what do I have here? I'm trying to remember what I have here. Okay, so yeah, I'll just keep this example. I'm not sure why it's in this class right here. Okay, so let's just look at method, create a new class. I'll call it this. So we want to compute the average. It's really very short. So public static in, oh, I said double, right? And then get average. So we want to make sure that that's, at some point, we make sure that the quotient, either the numerator or the denominator is a double, and then int, I don't know if I call it, it doesn't really matter what the name is. Okay, so we want to return a double value. So what I'm going to do, I'm just going to declare, what we're going to do is we're going to, remember, what is the average? We're going to add up all the values in the array and then divide by x dot length. So that's all we're going to do. Okay, so let's just find the sum. I'm storing it in a double value because what I'm going to do is return sum divided by x dot length. So that's your average. I mean, it's a double, right? Sum is a double. We're returning a double. We're not going to lose precision. It's because it's not integer arithmetic. The numerator is a double. Okay, so then, and then, okay, so then for every integer num, let's say in x, we're just going to add that on to sum. Let's go, sum is assigned sum plus x. So you find the sum, so compute the sum, and then here you just return the average. Yeah, so we don't want to divide by x dot length inside the loop. Get the entire sum, and then just divide by the length one time. Okay, so let's just see if this works here. How about, that's 3, and how about 8, 9, let's say 8, 8 would be 10. Okay, so then the average will not be, okay, so let's just, okay, so double av get average, and we're going to pass an ARR. And then with this, I'm not going to do a lot of, why is, oh, here we are, system.out.println. Okay, so then why am I getting a sum, oh, double sum for every, oh, I see, I did the same thing the last hour. Why am I getting, it's because I put the exact same thing in the previous class, okay. Yeah, I put plus x is the name of the array. Okay, so for every, yeah, we want to sum over num. So the first time for our problem, the first time in that loop, num is 1, and then it's 2, and then it's 8. In fact, why don't I just, I don't need it, but let's just print out the values of num, just so you can see how it's going through that array one by one. We're not using indices because we're using a for each loop. The average is like 11 divided by 3. It should be. And that's about right. 11 divided by 3 is about 3.6. And you can see, yeah, the for each loop was first, num was 1, and then it was 2, and then it was 8. And then, and so you'll do something like that on your quiz, write a couple of these. And then here, let me just look at, what was it, get largest? Let's do, with the wrong instructions. So let's just do one more. And then I have another example I want to show you. It won't be on the quiz though. Get largest. We want to get the largest value in this array. And and let's just see here. I'm going to do that. I'm going to try this off the top of my head. I may have to change this. Okay. Okay. So we want, okay. So int largest, and I'm going to see if I can remember this off the top of my head. Integer dot, of course I can't. Integer dot, is it max int? I think that's wrong. Yeah, that is, let me just look this up. Instead of just doing this off the top of my head, which I shouldn't do. Okay. I think, but I want to do it this way, integer. Otherwise, I'll go back to just saying, otherwise I'll just assume that the first one, x of 0 is the largest. If I can find it here. This is taking too long. Okay, so, oh yeah, max, min, oh yeah, it's min value, it's min, not min, it's min max, integer dot, okay, min value, there we go, this is what I'm looking for. Okay, okay, so in this case, that min value is, and you could also say largest is a sine x of 0 is another way of doing it. Assume the first one is the largest. Okay, so equals smallest int in Java. Okay, so then we're likely that so x of 0 will be larger than that, unless x of 0 happens, unless they all happen to be min value, in which case then that I don't think you'd ever see that assigned to an integer rate. It's in magnitude, it's a very small. I mean, it's a negative number. You go way far to the left on the number line. Okay. Okay, so now let's just see here. So for every int num in x. Okay, so if num, the latest number is greater than largest, then largest is num. So in this case, so instead of going, if num is greater than x of I, we're just going is num, or if large, yeah, instead of going if largest is greater than, our num in this case is x of I. So if num is greater than largest, right, okay. So if x of I is greater than largest is x of I. That's what we would do in Math 130. But for each loop, so for every num in x, okay. So we're not using indices because you're using a for each loop, and then you just return large. So let's just quickly go over this again. Okay, so we want to return an integer which is the largest value in the array. We're going to assume that we're not going to consider the case where x is null. In this case, I initialize largest to the smallest possible integer value you can have in Java, because it's every integer gets 32 bits of memory, so it's the smallest negative number you can store in 32 bits, and then we ask ourselves, is num greater than largest? Well, likely is the x of it's not too often that we use some negative number that's huge in magnitude. So if num is greater than largest, okay, so the first time that's probably true, and then so the first time largest would probably be the first element in the array. So we keep going through the array and see, is there something greater than largest? And then let's just print this out. So in this case, let me just put some more numbers in. I'm gonna just, how about, because the largest is 100. Okay, so let's keep this simple. Largest is largest plus, and then get largest. No, I'm sorry, AR. It should print 100. Yeah, 100, right? we can do this again. Let's just put a new number in here. How about 200? So now it'll print 200. You see what happens is when we, and again, the important thing is to be able to write these. I know this is, I did this in my class last semester in 130 with the regular ordinary for loop. The point here of these problems is make sure you can do those kind of problems now with a for each loop. Yeah, so the first time in the second problem, the get largest, the first time num is 1, and then num is 2, and then num is 100. Yeah, we totally ignore the index. So, and I will put my last year's quiz up too, but so you'll write there'll be one or two methods like this, but are there any questions right now? The important thing is to know how to write a loop with to know how to use the enhanced for loop. And now I have kind of an advanced example here, which you will not see in your quiz or your test. And this will be the last new thing I'll talk about. See if I can I already wrote it. My file names are not probably what they should be. Okay, so there was actually this third problem here. Let me just see that number 8. And I wrote this two ways. In this case, we have a two-dimensional array, which represents an array of objects. So I wrote actually the example I wrote it two ways. One where we have we'll look at the second way. Maybe it's a little bit easier for those of you, maybe just need a little review. Remember object with the uppercase O. It's the class, it's the top level class. And you can have an array of objects. In this case, because you have the double square brackets, it's a two-dimensional array of objects. But just to remind you, Java really only has one-dimensional arrays. Remember, a two-dimensional array, every array is a collection. So what we call, and I use the term two-dimensional array. And what a two-dimensional array in Java is just a collection of one-dimensional arrays. So let's just look at this code right here. And what we're going to do is we're going to compute the number of elements in this two-dimensional array. We're going to use the length property. And here, let me just see here. Is it this one? Nope. Because my names are so bad here that I thought it was this one. Okay, maybe we'll just write the method here. Okay, so okay, yeah, I was writing. I was the file names aren't very good. Okay, because I kept using the same file in my last lecture for everything. Okay, so I actually have all the code written here. There's two versions of that num elements, and that's okay. They're both called num elements. See line 4 and 17, and that's okay because the input parameter is different. Remember, that's called a method overriding. When the method name is the same but the parameter is different. Okay, so what our goal is to, let's just look at line 31. We'll look at the code, the one that has a two-dimensional array of integers. And see, remember, in Java, a two-dimensional array is an array of arrays, and every individual array can have a different number of elements. So let's just add another one to this. How about one with 4, comma 1, comma -2, comma 3. Okay, so this two-dimensional array actually has four one-dimensional arrays in it. So the first one-dimensional array just stores 1, comma 2, and then 9, 0, 18 is the second one-dimensional array, and so forth. There's 4 one-dimensional arrays, and what I want to do is count the number of elements. So it's 2, right? So this first one has 2 elements, right? 2, and then 3, and then this one's 5, is this right? And then this one's 4. We're going to add them all up, and so it should be 14 if you add them all up. There's 14 integers stored in this two-dimensional array, and we're going to use the length property, right? Because every row, every one-dimensional array is a length property. So let's look at that code on line 17. And also, I'm going to just, okay, if ARR is null, then I'm going to return -1, no elements. That -1 would be no elements. Otherwise, let's return the number of elements in the two-dimensional array. So line 18, and I like using one return. So I declare this variable num and set it to 1. And then I say, well, in line 19, if the input parameter is not null, then let's just reset num to 0. So reset num to 0. Because now we're going to start, because now num is going to hold a sum. Maybe I've made that mistake before. If you keep it -1 and you're adding on all the lengths, it's not going to be exact. It's going to be off by 1. Okay, so now let's look at 21. Look at line 21. What is ARR? Look at that, look like 31. That array 2D, it's a collection of 1D arrays. So what is this? What is this? So for every, an AR, so like in line 17, the input parameter is a 2D array. So for every 1D array X in ARR. So the first time X would be the array storing 1, 2. Then X would be the array storing 9, 0, and 18. And then and so forth. So we pass at the array 2D, yeah. So X just moves down these 1D arrays. Okay, so all we're adding on to num, like line 19. So the first time X is the array 1, 2, so X dot length is 2. And the next time X dot length is 3, the next dot length is 5. You'll see, let's just print it out. So we're adding on the lengths, and see, I don't have to use a nested loop, right? I just use the length property. But if you understand, this is a really good example. If you understand this example, then I really think you understand arrays, because you understand that an array really just stores an address, and a 2D array is just a collection of addresses. Each address refers to a 1D array. So, and if you don't understand it, then the good news is that you have a growth opportunity ahead of you. If you understand it already, well, that's great. But the people who don't understand have this great, something to look forward to. So, okay, so let's just run this, okay. Hello, run this, run. And as you can see, I'm printing out I just did that just for debugging purposes, printing out the length of as we're calculating the number of elements in the array. As you go from array to array, we'll print out the length. So 2, 3, 5, 4, of course, the sum is 14. So it's this one. No, of course, I should be more organized here. Okay, hello, this is not good. Okay, so let's not this one, and not this one. What was this one? Okay, so, here we are. Sorry, students, I got lost which file I have. Okay, so yeah, you can see here. Yeah, so this is that printout. It printed out 2, 3, 5, 4, right? Because every time we went to a new array, we printed out its length. So the first time I print out the length of the array storing 1, 2, and then the length of the array storing 9, 0, 18, and so forth. So I think this is a really good example. You don't need it for your quiz, but I think this is a really good example. So if you're into, so this is what I think I said for the last class. So there's a lot of areas of computer science. So if you're like the traditional 4-year college degree, computer science, if this is really just keep it, we should like what we're majoring in. So if this is oh my God, this is so awful, then you might think, well, I just can tell you, you've got a lot of this coming ahead of you. But because I really think programming, a lot of it is just bookkeeping. Really, you have to lots of little details. I mean, I'm not saying this is all what computer science is like, because it's really not. There's so many different things you can do in computer science, web development, and there's database and operating systems and compilers, and the apps that for our phones. A lot of that is not taught in in this 4-year degree type thing, like the apps. Maybe you might learn it in the business school. Also has comp sci, but maybe more like web development, and maybe they might have a apps. I don't know if they do. But to develop an application, you really do, at least for Android, and I think it's true for the iPhone, I think you really do need to know object-oriented programming, because I know the Android, the Google phones are all based on Java. And then the iPhone uses their own language, which I can't quite, I used to know the name, some version of C. I think it's some kind of C with some of the harder features removed. I can't remember the name of it. Okay, anyway, it's kind of fun to use. Okay, so students, I'm going to stop sharing and stop, probably because I've been talking too much today. So I'm going to stop sharing, and okay, I think I might actually stop the recording.